What's the antiderivative of 1 plus x squared over 1 plus x to the power 4? One way is that we could go with the splitting the rational function by factorizing the bottom and then splitting into several rational functions and then solve for each antiderivative of each rational function. But if we observe carefully, maybe we can divide everything by x squared and see what happens then. So we can divide the top by x squared and have 1 over x squared plus 1. Bottom we have 1 over x squared plus x squared dx. Now, if we observe carefully, I want to ask, what's the antiderivative of the top? What's the antiderivative of the top? Just the top. So this is easily negative 1 over x, simply because the derivative of 1 over x is just minus 1 times minus 1, positive 1, then 1 over x squared, this term. And 1 is just x. So this is the actually antiderivative of this numerator. So this leads to us to think whether or not we can rewrite the bottom as maybe x minus 1 over x quantity squared. And then, of course, when I expand the prefix square, I have x squared plus 1 over x squared. Those two terms. And I also have minus 2. Just 2 times this and that. Minus 2. But then I have to, of course, plus 2, just so that everything remains the same. Copy down the top. Okay. Now we can see that this quantity inside is exactly equal to our antiderivative here. So this is a clear indication that we should make some substitution and let this quantity equal to t, or u, or whatever. So let x minus 1 over x equal t. Then, of course, dt is 1 plus, like I said, this is t, dt is this, 1 plus 1 over x squared dx. This is exactly the top. Okay, then we can successfully rewrite the integral as the integral of, replace the top with just dt. The bottom now becomes, this quantity is t squared plus 2. Then we're going to integrate with respect to t, and then substitute it back to x. So, if I can just factor out 2 out of here, then I, of course, 1 over 2 coming out in front of the integral, just the coefficient integral of dt. Then I have t squared over 2. Because if I subtract 2 out of here, then I also have to divide t squared by 2. Then I can rewrite as t over square root of 2, quantity squared. Right? If I square everything, it becomes 2 at the bottom, t squared at the top. Still the same thing. Plus 1 dt. Then this kind of looks like a antiderivative of arctangent something, arctangent to this quantity. Because if it's arctangent u, it's going to be, if you differentiate arctangent u, it becomes 1 over u squared plus 1. So this is just like my u, this whole entity. So then maybe I can just say I is equal to 1 over 2 arc tangent, and then we'll figure out the coefficient later. There has to be some coefficient in front of here. So arc tangent of t over square root of 2. Of course, plus c. Don't forget constant. Okay. If we differentiate arc tangent of t over square root of 2, of course we would derive 1 over t square over t over square root of 2 square plus 1. Then I have to using chain rule differentiate this quantity. So it is just a constant coefficient just comes out here. So I have to, in order to cancel out this coefficient, I have to multiply by its reciprocal. Reciprocal of 1 over square root of 2 is just square root of 2. So again, I have to times square root of 2 up here. So when I differentiate this will exactly become that. Okay. Of course, I have to substitute t back to x. Remember, t is equal to what? X minus 1 over x. So this becomes I equals square root of 2 over 2 arc tangent quantity square root of 2 at the bottom, t at the top, x minus 1 over x quantity plus c, of course. Okay, now I'm going to have to double check by differentiating this thing with respect to x, if I can successfully end up with this quantity, this integrand, whatever you call that, integrate t or whatever, then that means I'm doing it right. Okay, respect to x. First, copy down the coefficient times 1 over quantity, this quantity squared plus 1. So I'm just going to leave out the 1 here, because in the end we'll have something else on the top. So square root of 2 squared becomes 2. X minus 1 over x quantity squared plus 1. And then what will we have on top? Simply we will have, applying the chain rule, differentiate this quantity. Of course, we will multiply this coefficient 1 over square root of 2 out here. Of course, then we differentiate x and minus 1 over x. That will give us 1. So derivative of 1 over x is just minus 1 over x squared. So that's become plus 1 over x squared. C is gone, becomes 0. Now, simplify this term. Square root of 2 is gone. So we have 1 over 2. So 1 over 2 multiplied by, copy it down the top, 1 over 1. 1 plus, this becomes 2 at the bottom. Expand the bracket. X squared plus 1 over x squared. And then we have minus 2. Multiply this and that, multiply by minus 2. Minus 2. Plus 1 becomes plus 2. So we have a common denominator of 2. So this will just simplify down to this is gone. So this is actually equal to 1 over 2 1 plus 1 over x squared. 2 at the bottom. 1x squared plus 1 over x squared. And that is equal to 1 over 2 times, this is our numerator, this fraction is our denominator. So when you divide by some fraction, you need to multiply by the reciprocal. So the reciprocal of this fraction is just 2 over x squared plus 1 over x squared. So multiply by 1 plus 1 over x squared. So let's just flip this thing upside down. So 2 is now on the top. Top becomes the bottom. X squared plus 1 over x squared. And we can simplify 2 and 2 here. Gone. We're left with this. Further simplify by multiply everything by x squared. So that will give us, top we have x squared plus 1. Bottom we have x squared, x fourth plus, this is cancelled, plus 1. Okay, does that? Okay, yes. That means we're correct.